Thank you, good students, and feel welcome. I just want to take you through the study of frustum to see how to find the volume of a frustum. I've provided a sketch of a frustum there, where the H2 is the height of the origin of cone. H1 is actually the height of the cone that was chopped off, and then the respective radius, the upper and the lower radius are given, one in capital R, the other one in small r. Now, once we know that, I want you also to realize that from this particular diagram, it's clear that h, the height of the frustum, is indeed h2 minus h1. The difference actually gives you the height of the frustum. Now, I want you to recall this, that in terms of similarities, because we assume that the frustum that is cut up or chopped off is actually similar to the whole frustum. Therefore, applying that similarity and enlargement, you can realize that in most cases, r over small r should be h2 over h1. That's one. Or this one can also be taken to be true, where we have r over capital R is equals to h1 over h2. Now, I'll consider this one case 2 and case 1 separately to see how I'm going to derive that particular equation or formulas. Now, to start with the first one, I want you to take for the case 1 and we subtract 1 from both sides. Now, we are going to have r over r minus 1 equals to h2 over h1 minus 1. Now, once I've done that, if I try to put them together, including that one, you realize that we are going to have r minus r over r is equals to h2 h1 over h. But you can remember that h2 minus h is actually h for that particular case, and therefore this one can be written as equals to h over h1, that is r minus r over r, right? Because what is here is actually indeed h. Now, making h1 the subject, this particular one here, we remain that h1 equals to r h over r minus r. I want you to master that particular relation, and I'll call it 1. We are going to use it somewhere where we are said that for this case, our h1 is going to be r minus 1. Now, to proceed on, I want you to do the same using this particular relationship. I used case 1, but I want us to use the second one, which for this case is now r, the reciprocal. I've just interchanged this, equals to h1, h2. And then again, I want us to subtract 1 on both sides. If I do that, then you're going to realize that I'll have r over r minus 1 is equals to h1 over h2 minus 1. Putting them together, we can try to put them together and see what is coming up. Let's put them together. For this case, you're going to have r minus r capital over r is equals to h1, h2 over h2. Again, realize that h1, h2 is indeed h from here, and therefore I'm going to have r minus r is equals to, but a negative one because one is larger than the other. So, but this one is going to be negative h over h2 over r. But remember, also this one will give us a negative number. Therefore, I can interchange this one so that it cancels up. And therefore, I'm going to have what? I'm going to have r minus r over r is equals to h over h2. Now, once I have this, then what am I supposed to do here? I'll come to the other side so that now I can try to relate this one to what I've covered. Remember, I can make h2 the subject, which now I'm ending up with h2 is equals to capital RH over R1, not R1, rather than R minus R. That's what you're going to get. Now, once you have this, remember this, once you have H2 and H1, remember H1, if I can recall, is R small h over again R minus R. So these were the values that you obtained for what? for H1 and H2 respectively. Now remember, H2 was the height for the original cone, and H1 was for the height that was chopped off. Now I want you to recall this, that volume of a frustum is gotten by pi r, capital H, the original cone, which is H2, minus a third pi r squared H1. Are we together? That means that the volume of the original cone minus the volume of the chopped cone, the remaining one should actually be the volume of the frustum. Now, if I try to simplify this by putting R, H2 and H1 in that particular equation, you can see that volume therefore is equals to, remember, a third and pi are common. Then I'm going to remain with R into RH over R minus R, close it, minus R into RH over R minus R. Then I close it. So we are going to have two relations like that. And if I was to expand, then you can see coming up, we have a third pi, then we have R squared, right? Then H over R minus R minus R squared H over R minus R. Right, together. But this one is supposed to be squared. Let me not lose it out there. So this means if this is squared, this is going to be cubed in that manner, because R squared times R is R cubed. Now, once you are at that particular point, then we can say V is equals to a third pi. H is also common. I can take it outside. And then I'm going to have this one reducing to R cubed minus R cubed over the difference R minus R. So this particular formula that is coming can actually be used to work out what we call the volume of a frustum. For that case, that we can say the volume of a frustum is just a third times the height of the frustum, R cubed minus R cubed over R minus R. I want to call this one as the first formula for that case. But alternatively, from this particular formula, which you've gotten as volume is equals to a third pi height into R cubed minus R cubed R minus R, we can actually simplify this particular formula. Remember, we've said what? There's something that you've said about this one. We can simplify this particular formula by doing what? This is actually a difference of two cubes. And therefore, we can say volume is equals to a third pi h into, this one is going to be R minus R, that's the first one, into R squared, capital R squared, and then this one is going to be plus R dog, that is over R minus R. Remember, this one will cancel up, and therefore this one is going to reduce to be volume is equals to pi and third, and then pi h into R squared R. Now, in other words, we can actually get the volume of a frustum by taking a third pi multiplied by h, and then into bracket the sum of R squared plus R squared plus R, then plus R, the product of the two radius. Again, that one can still give you the formula that we are interested in. Now, if we proceed on and maybe try to simplify this particular equation, then I can say that volume is a third pi into, remember this one is, there was h here, r squared, then you have r, like this one. But what I want us to do in this particular relation, I want us to multiply this pi in, and you're going to have this one reducing to, we can have this one coming up to volume equals to a third h into pi r squared, you see, plus pi r squared, and then plus a pi capital R in that manner, right? But I can use a clean sheet so that you can understand what I'm trying to do. Remember, we have said that the volume is a third pi h, and then there is r squared, there is r squared, there is r like that. Now what I want us to do is this. From this particular formula, I want you to distribute a pi inside, and we are going to have a third h. Let's take pi in. We are going to have pi r squared, then we are going to have pi r squared, then we are going to have pi r. I've just distributed in the pi. Now look at this third part, which I want to do it aside. You know, this third part, I can write it as pi r, and then I square it, and then I do the square root. Remember, this part, by so doing, I've done absolutely nothing to it, because after all, if I square this and then I do the square root, I come back to this particular question, and therefore I can write it as a half, a third, and then h, pi r squared, then I introduce this one inside to have the square root of pi r squared, pi r squared. Remember, at this point, this one will be r squared, and this one will square, and this will be pi squared. So pi and pi will be pi squared. But by the virtue of the square root, I can still go back here. Now, if that is the case, therefore, we'll have the volume, therefore, is equals to a third h into, now this one is actually the area of a circle. Let me say area 1 plus area 2 plus the square root of area 1, area 2. Then I close it. So you can see from this particular equation that the volume of a frustum can be gotten by taking a third height of the frustum and then summing the areas of the respective circle, like the lower one, the upper one, and then product the two square root, then multiply by this one. Still, this one is going to give you the area of, or the volume of a frustum. And therefore, in conclusive, if I was to conclude this, we can say this, therefore, that generally, that is now a general case, generally, the volume of a frustum can be gotten by a third pi r squared h minus a third pi r squared h. You can do that. Now we've simplified this. Alternatively, the volume can also be determined by a third pi, we are putting that pi there, h into, now we said this one can be simplified into r cubed over r minus r. Alternatively, the volume can also be gotten by a third, remember, and then we are bringing in h, isn't it? A third, we are bringing in h into area 1, area 2, then the product, then we sum it, then we take the square root. And lastly, this volume can also be determined by a third, again, pi h, then into the radius squared, the other radius squared, the product of the two radius, that way. So any of these three formulas, either this, or this, can be used to determine the volume of any frustum, as long as you know the height of the frustum, the radius of the lower or bottom, and the radius of the upper part. Then you can use any of these formulas to do that. I believe you've actually understood that step by step of derivation of this formula. Thank you, and also remember to subscribe so that you can be notified whenever interesting lesson is posted. Remember to also follow me in my Facebook page at Teacher Oigo fan page. Thank you and be blessed.